NAT network address transmission. So, very important topic, especially later on. That is what happening with NAT. What is a NAT operation? So if you look at this picture, basically when you see some kind of movie, that's either those they are hiding themselves inside a different person. So this is just to give you some idea what the NAT could be. The idea is actually the IPv4 address is not big enough to address all the devices that connect. So we know in the chapter 2.3 discussed about the private IP addresses, private public IP addresses, RFC 1918. Used to basically these IP addresses are not routable. Private addresses are not routed to the internet. Public addresses, private addresses can be elevate IPv4, but because they are not routed, first need to be transmitted. NAT is performed to use such kind of transmission. Okay. These are the range of private IP addresses. 10.0.0. Please keep in mind this one in your head all the time, because many companies, the interview, they might be asking. Okay. 10.0.0, 10.255.255. Similarly, B, we have class A, class B, and class C. Basically, what happens on the router, one side is connected to the private network on this range, and one side is connected to the public. So basically, this is a typical example of your wireless router as well. One side your LAN address. Okay. So if I, for example, right now check the IP address on my router, you see I have 192.168.8.255. Okay, but when I go to the internet, I type what is my IP. You see this is 75.255.37. This is my public IP address. Basically, outside world, especially you guys are connected from, you are communicating to this router. Okay, not this router. So these are private range. The private range need to be translated into the public one. Okay. So this is the reason that this is called NAT actually. Basically, NAT is doing. So what NAT is? NAT is processing you translate the network addresses. NAT primarily uses the conserve the private public IPv4 because IP addresses are not many. Not That's why we can translate the private to the public range. NAT is usually implemented as a border router. NAT allows the network to use private addresses internally, only translated to public addresses when needed. Devices within the organization can be assigned private addresses and operate with public addresses. When traffic must be sent or received to perform other regulation on the internet, border router is doing a translation. Basically, you can see this as a typical example. So inside you have a LAN network 192.168.10.10. Okay, so this is all private range. And this is a NATed router. Once the traffic will be reaching from the private to the public, the router has the capability. They will change the your internal IP address into the public IP address. For example, 209.165.1 range. For example. Okay. Now, NAT terminology. Any questions so far? Inside NAT is the set of devices using private addresses. Outside network refer to all the network. NAT has 4 types of addresses: inside local, inside global, outside local, outside global. So let's see just in the diagram. So basically, what happened here at this router? See, this is the the boundary, this is the local addresses, this is the global addresses. Basically, inside network, those SA mean um, source address. Source address, inside source address, local address will be this. This is your actual IP address, okay, of your machine. Then it needs to go to the destination outside local, okay, and this is the source inside global. Your source inside global will be the IP address connected to your domain, your router outside, maybe ISP, and then it's talking to the outside address. Basically, this source address may be talking to this destination outside global address, right? And this this address will be changed into the public IP address. The outside world knows that this is the private range because they cannot communicate to this guy. They can only communicate to this guy. Okay. This is here you can see. You want to go. This is the source IP inside local, outside global. So inside, you want to from this router. You want this from this machine. You want to send the traffic. From this machine, you want to send the traffic to this website. 209.165.201.1. Okay, so this will be your outside local, inside local, outside local, because that's your destination address, source address, destination. Then what happened inside global? What will be the inside? So inside local and inside global. What happened? The inside local will be changed into the inside global address. So it will be masking. So on top of it, this address will be changed, and we get the inside global address, right? And then we can communicate on the other side. Okay. Okay, there are two types of NAT. Static NAT use one-to-one mapping for local and global addresses. This mapping now configured for the network administrator and remain constant. The static address is particularly useful when you host the inside network. So here you can see there are two types of NAT: static NAT and dynamic NAT. Okay, in our house we only have one public IP address, but when for the static NAT, actually static NAT use the one-to-one mapping of local and global addresses. This is static. This is one. Every time this machine will be interacting with the outside and the internet network, it will always get this IP address 203.312.182.8. 192 will be translated into this, and then like this. The static allow the mapping of the internal IP to the public. This means that with the appropriate firewall setting, the public access to the network. Basically, if you are sitting outside and you want to access this server, you will be also hitting this IP all the time, and you will be diverted to the actual machine IP. Basically, if you want to expose some of the server outside the internet, you use the static NAT. Okay. So, for example, here you can see a network administrator can SSH to the server inside the network by pointing the SSH line to the proper inside global IP address. Because they are one-to-one mapping. Let's say you are sitting at home and you want to do SSH to this server. But because this server actually the actual IP address, the inside and local IP address is 192.168.10, but the inside global IP address is actually 209.165.200.256. So you will be not, because this IP address is never reachable to this server, this machine. You will be SSH to this guy, and then it will be translated to this. That is why we need one-to-one mapping when you translate to one host all the time. Every time you want to go outside, you want to get one IP address. Okay. Now, what happened in the dynamic IP address, dynamic range? Dynamic uses the pool of public IP addresses and assigned to them the first come, first served basis. When the inside machine require access to the outside network, they get the IP from the pool. Dynamic NAT required that both have enough addresses are available to satisfy the number of simultaneously user sessions. So basically, what happened in the dynamic NAT, you can see all the guys you will see dynamic NAT address translation. There is a pool of IP addresses 226, 127, 128, 20. This is the pool of IP address. Every time you want to go outside, you might be getting any of the IP address from the pool. So unlike static NAT, actually, static NAT is just one-to-one mapping. Every time you go out, there is a guarantee you will get this IP. So the benefit would be that if somebody is outside, he want to access this server or this IP address, public IP address, he will be translated back to this actually all the time. For example, when I do the bbc.co.uk, this server is translating into the 212.582.33251. The outside world knows this IP address all the time because this IP in the DNS has the mapping entry of 218.58.233. It has to be the same all the time. Otherwise, if the IP is changed, then we need to update the DNS entry as well. So dynamic NAT actually we have a public, we have the range, we have the we have the range, and then every time you go outside, you get the IP address from that range. Okay, what is a PAT? So there are three types of NAT: static, dynamic, and port address translation. Port address map multiple private IP addresses into one single IP address. Similarly, this is the typical example of your wireless router. So inside your house, the many machines, computer, laptop, tablets are connected, printers are connected, and if they want to connect to the internet, there is just one public IP address is available. So how this is possible? PAT uses pair of source and the destination and source IP address to keep track of what traffic is belonging to internet. So basically, they build the table every time 10.1.13 is going outside, right? They will be getting the this 172.16 IP address, but every time you can see there is a IP address plus port as well. So the private IP addresses are many, but the public IP addresses are just one. So how the addresses are unique? IP address is the same, but the port is different. So you see the internal ports; these are the dynamically assigned port. Every time you go outside, there is one public IP, but the ports are different all the time. That is also known as NAT overload. By also using the port number, PAT forward the response packet to the correct internal device. PAT process also validate that the incoming packets are requested, thus adding degree of security. So it's providing the security as well. NAT and PAT NAT translate IPv4 into one-to-one basis between private IP arrays, and the PAT modify both addresses in the port number as well. So the only difference is PAT has the port number. PAT forward incoming packet to their inside destination by the referring to the incoming source IP. Okay, where with PAT there is generally one very few public IP addresses. PAT is also able to translate for that do not use the port number. Benefit of NAT: it conserves the legally registered addresses scheme, increase the flexibility of connection to the public network, provide consistency, and also provide the security because your internal IP addresses are hidden. Disadvantage is, of course, performance degradations can be possible, end-to-end functionality is degraded, end-to-end IP reachability, traceability is lost. Tunneling is more complicated. Initiating TCP connection can be disrupted. Okay, so that was the about